Hi, and welcome to another lecture episode at Data Science Labs. This one is about regular expressions, and we're going to dive into a basic introduction on the foundational principles and patterns used and help you get the skills and tools that you need so that you can be able to be comfortable with building patterns and understanding how to interpret patterns. Let me start with just a preface. Have you ever needed to extract or validate data, but you couldn't find an automated way to pull exactly what you needed? Maybe the pattern that you would need to have is a little more nuanced than, say, look for every file that ends with validated or is CSV format. Well, when you need to create these more intricate patterns, you can use something like regular expressions. It is a powerful, flexible way to create patterns in text and identify and extract those. This can be really indispensable if you need to do anything related to searching, filtering, validating input data, or transforming that data, right? So pulling a specific subset, doing some operations, or maybe it's text updating. So you need to find all corrections where you found some potential errors grammatically or doing a transformation to that. So in Python, there is a built-in regular expressions package. It is just with the letters RE for regular expressions. You just import it like that. And many other programming languages such as Java, C#, and Rust also have it native to their system. You'll also find that because RegEx is so powerful, it's deeply integrated into Linux, Unix, and Mac operating systems. And Windows also has it via Windows PowerShell. So, that's a little bit of a background of why it's so popular because of the power that it has. And in this particular notebook, we're going to cover those pattern operators and give you an overview of them, including look-aheads, look-behinds, quantifiers, character classes, and grouping, which control how patterns are matched without necessarily consuming the text. We'll also show you how to construct and interpret the regex patterns, and we'll highlight some resources for practicing regular expressions. So with that, let's go ahead and get started. Now, again, if you're already comfortable recognizing and crafting regular expression strings, since this notebook is focused on the foundations, go ahead to the next one. Check out some of our other resources, such as going through real applications and example problems, or getting familiar with the basic functions such as find all, search, and match. With that, we're going to go ahead and proceed. So let's take an overview of the different regex pattern operators. Now, to learn how to create regular expressions, we need to first be familiar with the operators that exist. I've created this table below, and it gives you a brief summary of the main operators, what they do, and their example usage. So I'll scroll down. It's, as you can see, a pretty large table, and we'll take at it piecemeal and go, line by line, and there'll be a little bit after this, but not too much. If at any point you feel overwhelmed, I just got to preface and say, don't worry about it. It takes a little bit of practice, but honestly, after a few runs, you get pretty comfortable, working with regular expressions. So the first operator that you need to be familiar with is the dot operator. Each of these, we'll cover what they do, the example tasks that they can be used for, and how you would create a pattern to recognize it and the example pattern matches that come out of it. So if you were to use the dot operator, what it does is it matches any character except a new line. So it's basically a placeholder to say, hey, I'm interested in anything except for a blank space, not a blank space, but a return character. And so, if you're looking to find, let's say, any word that starts with a C and ends with a T, maybe that's cat, cut, caught, or something like that, and it has to be 3 lines long, you could create the pattern C.T, and that would basically say, find me everything that has a C and a T and something in between, as long as it's not a new line character. Now, when we're talking about looking at something that starts at the very front of a string when we're doing pattern recognition, so say we wanted to find something that starts with cat or starts with C.T, then we use the caret operator. And so this one, for example, we can put the caret on and enter a pattern after that, and it will basically send into the system that we want to find a string that starts with these characters. So if we were to do caret rat, R-A-T, with a capital R, it would return, strings. If the very beginning of that string was rat, or rather, or rat-like, or rattled, it would pull that and bring that back to you. The next operator that we're going to cover is the $ operator. What this does is it matches patterns at the end of a string. So you've got one for the beginning, one for the end. If we want to find something, for example, where we want to match the string that ends in ing. So if we have a full text and let's say we've got a list of different sentences and they're broken up into different lists, and one element in this string, and so each element of this list has a string array that has may or may not end with present tense verbs. Then you could check with this kind of pattern. So we put ing with a $ at the end, and then you might find words like running, jumping, hiking, walking. Now again, this applies if it ends the string and terminates the string. So if it doesn't terminate, you're not going to get a match. The next one, I think this is perhaps, the next two are perhaps the most common, most useful that you'll find, along with the character class. So this one, the asterisk, it actually helps us to match a preceding token 0 or more times. So this is useful if we want to find anything that might be repeated multiple times, but it's not a hard and fast requirement that character exists even at all. So this could be useful if we expect for something like misspellings, if in the lexicon, if you're dealing with normal linguistics and text data like on Reddit or Facebook or some other social media sites. You think of the different languages and text where people say something like yeah or like wow, these different exclamations where someone might put a ton of Y's on it, or maybe they'll just put on like one or two, or they might forget and mess up and there's not even a Y on there. In this instance, you can put the the asterisk operator after the variable that you are interested in having potential repeating. So in this case, if we were to put candy with an asterisk, it would find potential matches such as CAND, canned, candy with one Y, candy with two Y's, or if you threw on like a million Y's, it would also return that one. Now say that you had a hard and fast, you needed to have at least one. It could be more, but it needed to be at least one. That's where the plus operator comes in. And so, same thing here. The only difference being it's not going to return canned. It will only find those matches like candy with one Y, two Y's, three Y's, and so forth. The next operator that we're going to cover is the question mark. What this does is it matches the preceding token 0 or 1 time. It's basically like an or, kind of option. I want this to happen or that to happen. And so, one of the areas that you might be thinking, well, where is this actually useful? It can really come in handy when you talk about areas where there are different ways to spell things, especially when you compare the English, American English, dictionary to the British English dictionary or other forms, of language. So if we look at, for example, how to spell color, if you were to do that in the United States, that's COLOR. But if you are dealing with data that is global, where you have multiple people from different countries, they might spell it CLOR, CLOUR, and so forth. And so we can use the question mark operator and put that next to the optional character. So here we've got COLOU question mark R, and that basically means, hey, it should have a U or not. This is an optional character. And so it will bring us back either of those two matches. The next one that is very useful is the any digit operator. This comes with having a slash and then a D followed by it for digit. Now the slash is significant. We'll cover this on a couple other operators as well, but basically the slash denotes that it is a unique special character. Otherwise, if you didn't have the slash on it, you would just have a D and it would just match on the D. But having the slash with the D next to it tells us we want to find any numerical digit. So if you had just that single one, it would pull back and provide matches like 4, 5, 1, 7, 2, 3, and 3. Say you want to find bigger numbers or any numerical pattern that might be one or more digits, and then we combine this operator with the plus operator or the star operator, and then if we do it with the plus operator, you can see we'd get options back like 42, 2025, 3, 17, 00, 007, and so forth. Next one that we're going to cover is the bracket operator, the set, I should say, where you put n in this set. So if you put this in, it will match exactly n repetitions. And so you can basically put this after a pattern or after a particular character that you want to match. And it says, I want to match this character exactly this many times or repeat this many times. This can be useful if you're trying to find something that, like a phone number, type element where it's going to have a certain number of digits preceded by another collection of digits, and so on and so forth. It could also be useful, in any other aspect where you can see this type of pattern where you've got a known set of repeating. So, if we take this, you've got, for example, if I had 1 and then set 3, 2, set 3, and 3, set 3, this is saying, give me 3 instances of 1, followed by 3 instances of 2, followed by 3 instances of 3. And that's where you can see, 1, 1, 1, 2, 2, 2, 3, 3, 3. Suppose, though, that we want to find a range, but it's not exactly 3, but somewhere between like 3 and 5. That's where we use the set operator and we dictate between n and m repetitions just by adding that comma m. And so you can see that with the example where we find the number of digits between 2 to 4. So I'm getting a little fancy here, but you can see the /d operator. So that's, give me any digit that repeats between 2 and 4 times, right? Or matches between 2 and 4 times. So you can see here we're getting options like 1, 2, 5, 7, 6, and 4, 7, 8, 7. So the length of the string is between 2 and 4, and they're only digit-based matches. And they don't have to be the same digit each time. Now, the next one I think is where it gets rather interesting, and this is the character class. This basically gives you the opportunity to treat something like a giant OR operator or transitional slide. So it lets you match any one character inside. It's basically a way of saying, hey, I'm going to stuff a bunch of different variables or patterns in this list, and I don't care which one is found. If any of these are found, match it, and then show that to me. And so in this character class, if we wanted to match any vowel, we could do A, E, I, O, U, and maybe sometimes we'll even put a Y in there. And what this would bring back would be any time that pattern is specifically matched. So whether it's an A, an E, or a Y, we'll get that returned to us. The next one is the negated character class. So imagine instead of vowels, you want to find consonants. Well, you could list all the other letters of the alphabet, but it could also just be easier to just put a caret in front of those vowels, and you would just pull those back. Another example would be, say you are looking through a numerical document and you know that there are improper, let's say corrupted data in there. You could put a caret operator on there to negate the match of any numerical digit. And so this would bring us back, stuff like the letter A, a hashtag, or an ampersand, question mark, exclamation point, or something else. The next one that comes in handy is the word character. So say you want to match any letter, any digit, or a underscore. You just put the slash and then a W. And so this will let you match any word-like string in a text. So this will match hello world if you have an underscore in it, or hello. It will not match hello world if there is a space between them. And it will match, yikes, 976, anything you can think of like that. Now, if we need to have white space that we want to match on, or we have text that has a white space character in it, the way that we dictate that would be having a slash followed by the S character. So /S for space. And so we can use that. Let's say it was going to repeat many, many times. Then we can look at and put the /S plus operator. So that would return back any space, a tab delimit, a new line, or a return line. The next is the parentheses. This gives us the capturing group operator. So this can be useful, especially if we're doing something such as using the find all function. We'll get into the specific functions again in a later video, but say you wanted to have multiple patterns that you're trying to pull. For example, let's say we're going through a phone directory and we want to pull the name, we want to pull a phone number and the address, and we want to load that into our database. Well, by having the capturing group, we can create a specific pattern to capture the phone number, one for the address and one for the name associated with it. The next one that we have is the OR operator. So if you had a long string of text, if you recall before, we showed the question mark, which is specific for a single token. In the OR operator, this can be used for an entire pattern. So if we wanted to match cat or dog, we just put, again, the slash and then your straight line operator. The last two that I think can be useful, these take a little bit more practice for most people, generally for most people to get comfortable with, is the positive look ahead and positive look behind characters. The difference here in the look ahead, we've got the, you see that again, the grouping, capturing group, we've got the question mark equals. So that says, hey, I'm going to do a positive look ahead on this string. And then you put your pattern after that. And the other one is going to be the positive look behind, which is you're going to, put the question mark, have your, less than or equal to, and then have your string that you're going to have it look behind for. So if we wanted to match, for example, a word that's only if it's followed by a period, we can put in the string, okay, I know I want a word. It's only followed by a period, so we can use the /w plus. So that's going to be any, word-like character repeated at least once or more times. And then it has to be followed by a period, so we'll put in that question mark equals and then the slash dot. And the reason we have a slash dot is, again, to signify, this character is not the dot operator, it is truly the dot symbol. Now, we can, as you've seen in some of these, we can combine any of these operators if we need to, right? So if we want to find any digit that repeats multiple times, or find, like match any word-like character, but not with digits specifically, we can take the word and combine it with a not operator for, digits. Now, if we want to handle special characters, just adding an important note for that. There are a few that we need to handle with those special slashes, as we had mentioned previously. Principally, they are the dot, the caret, $, asterisk, plus symbol, question mark, your left set, right set, left bracket, right bracket, your forward slash, your straight line operator, and your open and close paren. So when we want to match on one of these characters, it's important to have that slash character included. For example, in our phone number match, if we only want phone numbers that had the parenthesis structure, like in the US where you've got a 3-digit area code in parentheses, followed by a hyphen, followed by another 3 digits, followed by a hyphen and then another 4 digits, we could craft a pattern like this, where we've got this slash parentheses, slash digit set 3, slash close parenthesis, and then hyphen slash digit set 3, and continue and close it with the last hyphen slash digit set 4 close paren. That's one way that we could do it. There are obviously other ways, and what you'll find is that there are many ways to create and craft patterns. So a lot of this is that practice of what is a easy pattern to make, what's one that's easy to read and interpret, is this efficient, and then also am I handling my edge cases. With that, I know that's been a decent overview into the different operators, so let's dive into some practice problems. Now, if you're interested in any of these problems and want to go ahead and practice them on your own, go ahead and check out the link in the comments. I've added the notebook that you can access, and all you need to do is make sure that you've got Voila, Python package installed, and you just call the notebook with Voila, and then it will launch to your environment with the homework style kind of quiz questions and buttons to submit. So let's get started, and you can pause this video at any time. if you want to do this live and not have any help, right? But feel free to pause play at your needs. So for the first one, let's say that we're using RegEx and we want to find which of the strings we captured with the pattern CAT, all lowercase. This is going to be cat, the top one, any of these iterations of cat, or catatonic. Well, I'll give you a second to think about it. And now let's go through the reasoning for this option. So the answer is going to be cat, and the main reason for that is that RegEx patterns match explicitly. They are case sensitive. So if you put CAT, not capital, it's not going to match cat, or cat with one capital C. Now, as to the dot wildcard, we're going to look at which of the following would be identified with pattern B dot T. Remember that the dot operator can be anything except for a new line. So that should give us, bat for sure, bot. It has to have a T there, so it's not going to be bin. It could be bit or but. But again, we're looking at the 3 character, so it's not going to be byte. Next, we'll continue on to the character class. So which of the following would be identified by the RegEx pattern? And we have the brackets, again, the character class. So you've got C, and then you could have A or U or O, followed by a T. So in this case, our options are either cot, coat, cat, cut. Now again, this is just looking at the, basically treated like an OR operator or an any operator, find any of these elements. And so it's not, the number of repetitions have not been given an optional condition. It's only allowed to show one of those items once. And so it's not going to be coat because of that. We would only have cot, cat, or cut. Regarding the multi-character class, so now we'll look at where we're using the character class and we're nesting them together. So what would be returned by the following pattern that we have? It's A-Z and 0-9. Now this is an interesting one. If you will recall, A to Z, or A-Z literally means A to Z. So any character from A to Z. 0 to 9, any digit 0 to 9. Now an important caveat, as I mentioned, RegEx is case sensitive. So you're not going to get anything capitalized. And again, it's going to be one character followed by one character of the other. So not AT1, it will be B4, S7, but not 0C, because again, the direction, the sequence is also significant. So with that, let's continue on. We'll proceed down to problem 5, the multi-character class with the dot operator. So if you want to look at a pattern A to Z dot or plus operator, and then 0 to 9, what could this be? Well, it's the A to Z characters can be repeated any number of times, at least once. So that could be apple 1, and it could be A7. It's not going to be A007 or agent 007 because that would require the plus operator to be after the 0 to 9 character class. Next, with the star operator or asterisk for multi-character class, as we just covered from the last one, this one would be the opposite, or almost the opposite. The only difference here being that 0 to 9 can be repeated 0 times, meaning that, so we know 7 mechanics is not valid, but we know 1577, that could occur, 30 with the single digit 9, mechanical would be fine because there's no digits, and quantum would be fine. Now, if we want to look at the word character operator /W+, which of the following would be identified from that RegEx pattern? Remember, this is anything that is a word-like string. So it's going to be any letter, any number, and any underscore. So, we're going to get stuff like howdy, yes sir 77, hello world. We're not going to get sure thing because of the space. And we're also not going to get right because of the exclamation point. All right. If you have any questions, let us, feel free to let me know in the comments. But we'll move on to the question mark operator. So which of the following would be identified from the pattern T question mark OO? Again, the question mark, remember it can occur once or 0 times. So the question in this problem is basically, does that question mark belong to the T or does it belong to the O? And if you recall from where we applied color, we can go back up to that on the table if you need for help. So here for color, we put the question mark after the value that we want to be optional. So if I go down to 2, our example problem, we have 2, TO, and OO. In this case, the options are effectively telling us. So we put it after the optional character. And so here, your options are going to be 2, because one of those O's could be optional, or OO, because the T is the optional character. Next, we're going to cover if we want to match any potential valid email address. So this is a little bit more nuanced of a problem, but if you want to look at any email address where the pattern would work, let's assume that hyphens and spaces are not supported, but you want to create a string to do this. This will be a bit of a step up, but think through a couple different ways that we could do this. Well, we know we want to have, usually it could be someone's name. Email addresses are always going to be continuous. So a word-like character would be fine. It's going to have the @ symbol, and then something like .com or .org or .gov. We might be tempted to look at the first one, and that one seems pretty close, However, the reality is that if we're looking at that one, where is the dot? It's not there, right? And so we'd want to have that dot condition. So it's not going to be this one because it doesn't have that period. Otherwise, everything is satisfied. If we look at the next one, you got A to Z, so all lowercase, all capital, any digit, a dot, or an underscore, or a percentage. This might be a little messy, right? With a percentage, not many email addresses would support that kind of character string. So that could work, but it's highly unlikely. So that could be an edge case, but again, we don't have the .com, we just have @com, org, or gov. So these two don't work, but then if we look at the next one, you've got any word character, and then @.com, .org, .gov. For sure, this one works, we know. And if we look at the other ones, any word character, @com, gov, or org, that's the same problem we talked about before. And then also, if we look at our other options, we have com, org, or gov repeated any number of times, at least once. That's not going to work. And then also, if we're looking at this, we have the set, com, org, or gov. That could also be tempting, but remember this OR operator is also acting within the character class, and so really, it's not a true pattern match on com or org. So it's not going to be that one. Excellent. So now we're on to the last problem. This one's going to be a bit challenging, right? Similar to the last one. So go ahead and take some time to think through this one or pause this one. But this is pattern comprehension. So we've got 4 different options. For what text would match this pattern. We've got, as you can see, the character class and multi-character class being used. If we were to distill and just go through this line by line, that might help in interpreting this. So first, you see we've got these open and closed parents, so that's one grouping that we're looking at. So it's good to kind of digest this from the outside in and then look at it and chunk it from there. So first off, I see, okay, we've got one grouping. a space character, this is the /s, so a white space, and then another grouping. So if I'm looking at that, each of these, hit that, right? So they're both, a group of two groups separated by a white space. So that doesn't necessarily clarify too much right now. But then if I dig in on the first one, I see any capital letter, A to Z. That's not given a multi-character operator. So it's just going to be one of those capital letters. So that narrows it down from John Doe option B to only A, C, or D. But then if we look further, we've got A to Z repeated multiple times in a lowercase fashion. So that gives us either John Doe here or John Doe here. Then if we look at the next one, you've got A to Z, again capitalized just once, and then A to Z lowercase multiple times. So we know our option is A. Now, the last thing we mentioned that we would touch on in this lecture video would be helpful resources. So one of the things that I think can be the most powerful when you're trying to practice RegEx and get familiar with it is the website RegEx 101. There are many other ones that you'll find, and there are many different resources you can get to help, but this is the single most one that I would recommend for people that are new and learning how to create these expressions. The main reason I say that is you can see here on the web page that you have an area to insert your regular expression. So that's the pattern that you're crafting. And then your test string. So if we wanted a random one like the dog went bark and it was a lovely day. And maybe we'll say this in the context of like a Reddit comment or just something, right? Where we've got it tagged. So this is at, expeditious 11, right? Or some random thing. If this is our test string, we can start doing our regular expressions pattern match. So if we want to do any dot plus, see what is going to happen. And you can see how we're capturing that digit group. Or we want to look at and capture, let's say, A to Z, find anything. It's repeating at least once or more. And you can see all these different matches that we're pulling up. So it's really cool for real-time practice. As you can imagine, the amount of text you're allowed to load is somewhat limited. So you can't load like a whole 4 gig text file in here for testing, but it gives you a lot of opportunity for doing some sense checking. The other nice thing about it is you can specify the flavor of regex that you're working with. So whether you're doing PCRE, Python, Golang, Java, or Rust, you can specify that specific version. And so you can specify how that pattern is created. So it helps accommodate some of the slight nuances between systems. But that's the one that I'd highly recommend. There are other additional resources that you can find by Googling. And the other aspect, is that there's no shame in using your different AI tools, such as VS Code Copilot, ChatGPT, Microsoft Copilot, Grok, or some of the other models to create one. If you want to create a complex string, they're quite well suited and adapted to providing those strings back to you. The biggest thing that we'll cover, and if I go back to our notebook, is that, and let me go back to the end, is let me just provide a final note of caution in closing. There are many ways to create regex patterns. There's not a single right way necessarily in most cases, but there are many ways that you can mess up. Most of the time that's because you're creating a pattern that's perhaps too complex to interpret, so it's hard to understand and hard to error check. Other options are that you've created one with the effort of being simple and you don't check for all the edge cases. So these are two fundamental aspects that we always want to focus on and ensure we are sensitive to when we're doing these trade-off studies. For example, if we want to look at the outcome of how many ways we could pattern match on a phone number, I've just provided on this below 3 different ways that we can match a phone number. And so you can see how we've got any digit repeated 3 times, then 3 times, and then 4 times. And then we've got another one that's the 0 to 9 3 times, 0 to 9 3 times, 0 to 9 4 times, or you could explicitly do that 0 to 9 written out 3 times. Each of these work. One is a lot easier to read than the others. And so when it comes to validating or checking, that one's a lot easier to read. But the other thing is being cautious, where if we put like any digit and had the plus sign on it instead of the set 3 or set 4, that's going to give us something like 999 with 2 digits or 100 digits after, and it's going to bring that back as a valid option. This might seem trivial, but it's kind of important if you're doing anything where you're pulling out VIN numbers, social security numbers, anything you can think of that is a specific character set where it's got that pattern and a specific number of digits. You want to make sure that you are explicit in what you are trying to capture. So to wrap up, in this video, we've gone through a very brief overview of regular expressions. We've gone through the background as to why they can be helpful. We've reviewed the table of different pattern operators. Next, we highlighted the special handling of character classes and then gave you a list of practice problems. And then lastly, we touched on different useful packages you could run with. So that's all for today's video. In the next lecture, we're going to cover the 5 basic functions of regular expressions. So if you're thinking now like, hey, this was helpful, but where are the actual pattern strings? And I want to practice writing those, typing those, and doing an immediate validation. Let's do some raw coding. That's going to be in the next video. So go ahead and check that one out. But if you've liked this presentation, this quick overview, and you found the content helpful, go ahead, hit the subscribe button, and you'll be able to see the new videos as they're released. Thanks again for your time. I hope it's been helpful, and we'll see you again at Data Science Labs next time. Thanks.